If you were wondering what could possibly be at the center of our neighborhood galaxy, the Milky Way, let's just say it's terrifying to say the least. The very entity that binds all of the galaxy's stars and solar systems together is an infinite source of destruction as well. Scientists had hypothesized it years before, but it has taken us until now to finally get some answers. Are these answers enough for us to understand how our galaxy actually works? Or will we still be in the dark? Back in the 1980s, two teams of astronomers began tracking the motions of stars close to this mysterious source of radio waves. They found stars whirling around a dark object at 1/3 of the speed of light. These motions were evaluated to be a black hole 4 million times the mass of the Sun at the center of the Milky Way. Reinhard Genzel and Andrea Gates would go on to share the Nobel Prize in Physics for this discovery. Currently, finding this big of a clue about a black hole is a huge deal, so imagine what it would have been like 40 years back. The size of a black hole is defined by its event horizon. That's the distance from the center of the black hole within which nothing can escape. And scientists had previously been able to calculate that Sagittarius A is 6 million miles or 26 million kilometers in diameter. The Milky Way's black hole is huge compared to the black holes left behind after massive stars die. This also led astronomers to believe that there are supermassive black holes at the center of nearly all galaxies, a hypothesis that's turning out to be more often than not. Compared to most supermassive black holes out there, Sagittarius A star is meager and pretty ordinary. On May 12, 2022, astronomers on the Event Horizon Telescope team released an image of a black hole called Sagittarius A star that lies at the center of the Milky Way galaxy. Sagittarius A star sits right at the center of our Milky Way galaxy in the direction of the Sagittarius constellation. For decades, astronomers have been measuring radio waves from an extremely compact source there, and this time they have proof of what's out there. If you didn't already know, black holes themselves are absolutely dark since literally nothing, not even light, can escape their gravity. But black holes are surrounded by clouds of gas, and astronomers can measure this gas to produce images of the black holes within. The central dark region in the image is a shadow cast by the black hole onto the gas, and the bright ring is the gas itself glowing. The bright spots in the ring show areas of hotter gas that may one day fall into the black hole. This is why you'll see this image to be rather similar to the one taken of Messier 87, which was revealed in 2019. Don't get mistaken though, they're two completely different black holes, and two being in exceptionally far places. Some of the gas visible in the image is actually behind Sagittarius A star. Light from that gas is being bent by the incredible amount of gravity the black hole has toward Earth. This effect is called gravitational lensing and is a core prediction of general relativity. This is why Einstein's works have acted as the pillars of understanding these cosmic giants. It's innately important for us to understand that supermassive black holes are extremely hard to measure. They don't just pop up on a random night sky. Firstly, they are incredibly far away and surrounded by the gas and dust that clogs the center of galaxies. Also, while we might think its core characteristic lies in the title itself, supermassive, they are relatively small compared to the vastness of space. From where Sagittarius A star sits, 26,000 light-years away at the center of the Milky Way, only 1 in 10 billion photons of visible light can reach Earth, and most of them are absorbed by the gas around it. Radio waves pass through gas much more easily than visible light, so astronomers measured the radio emissions from the gas surrounding the black hole. The orange color in the image are representations of these radio waves. The team used 8 radio telescopes spread across the globe to collect data on the black hole for 5 nights in 2017, and that wasn't at all an easy task for them. Even then, it took them 5 years to shell out an image for the rest of the world to see. Every night generated so much data that the team couldn't send it through the internet. They had to ship physical hard drives to where they processed the data. Since black holes are so hard to look at, there's a lot of uncertainty in the data these telescopes have collected. The data used to create an accurate image wasn't just a project on Photoshop. The team used supercomputers to produce millions of different images, each one a mathematically viable version of the black hole based on the data collected and the laws of physics. They then combined all of these images together to produce a final, beautiful, and accurate image. The processing time was equivalent to running 2,000 laptops at full speed for a year. That there is pretty darn amazing. As we've all come to know, the Event Horizon Telescope team in 2019 released the first image of a black hole, this one at the center of the galaxy M87 or Messier 87. This was revolutionary. I mean, it still is. The scientists had finally proven Einstein's works, and with these images, it's another extension of that proof. The black hole at the center of this galaxy, named M87 star, is an enormous 2,000 times larger than Sagittarius A star and 7 billion times the mass of the Sun. But because Sagittarius A star is 2,000 times closer to Earth than M87 star, the Event Horizon Telescope was able to observe both black holes at equivalent resolutions, giving astronomers a chance to learn about the universe by comparing the two. As I mentioned before, the similarity between the two images is almost uncanny because small stars and small galaxies look and behave very differently from large stars or galaxies. Black holes are the only objects in existence that only answer to one law of nature, and that's gravity. And gravity doesn't really care about scale. For decades, astronomers have hypothesized that there are massive black holes at the center of almost every galaxy. And while the M87 star is an unusually gigantic black hole, Sagittarius A star is likely pretty similar to many of the hundreds of billions of black holes at the center of other galaxies in the universe. There is a whole lot more that scientists can conjure from the data the team collected in the name of science. One interesting stream of thought could be the fact that the gas surrounding Sagittarius A star is moving at close to the speed of light. Sagittarius A star, like we've mentioned before, is relatively small, and matter trickles into it pretty slowly. To put that into perspective, if the black hole were the size of a human, it would consume the mass of a single grain of rice every million years. That's one extreme diet right there. By taking many images, it would be possible to watch the flow of matter around and into the black hole in real time. This would allow astrophysicists to study how black holes consume matter and grow. This new image has held true to the saying, "A picture is worth 1,000 words," so much so that it has already generated 10 scientific papers. We expect there will be many more to come in the near future, and as a space-loving community, we just can't wait. The first image of our galaxy's supermassive black hole has already begun to explain some of the greatest mysteries about the heart of the Milky Way. The wealth of new information about the black hole joins many other lines of evidence that are now forming the structure of knowledge about our galactic center. Taken together, the results suggest that Sagittarius A star is dimmer compared to the central black holes of other galaxies. The observations also hint that Sagittarius A star could have been spectacularly active only a few million years ago. Meanwhile, the latest data are raising fresh questions about some of the largest structures seen in and around the Milky Way. Eventually, we will be able to answer these questions with great accuracy. But for now, this black hole's data has a lot of eager scientists waiting to grab a bite of it. So, what questions do you think will be answered with the new data from this black hole's image? And do you really think every single galaxy in the universe is fueled by the central supermassive black hole? Let us know in the comments below, and as always, thanks for watching Space Rumor.